Okay, so let's go on. Let's go here. So the steps for balancing redox reactions by using the half reaction method are here. The first thing you have to do is separate them into half reactions. Second, balance each half reaction using the steps that I just taught you. Step 3, once you have the number of electrons that each half reaction contains, they need to be the same. So you would have to multiply one or both half reactions by a whole number to make sure that the electrons match, which will then change all of the coefficients in each half reaction, okay? Step number 4, add the half reactions together. Step number 5, if they tell you it's a basic solution, that is when we would add hydroxides to both sides to neutralize the hydrogen ions, but you only do this after you recombine the equations. Don't do the half reactions individually, okay? And then that's it. So let's take a look at these practice problems. Is this all that you have in your book, is just up to the practice problems? Okay, perfect. Okay. Let's take a look at number 1. It's kind of obvious in number 1 what our two half reactions will be. This right here will be one half reaction. They both contain AS, and then this will be the other half reaction. Okay, so I'm going to write my H3ASO4 going to ASH3 here. And then I'm going to go ahead and write my Zn going over to Zn plus 2 over here. Now, for this half reaction on the right, you have the same number of zinc on the left and the right side. So the only thing you have to do to this half reaction is add electrons. You would just add 2 electrons to it. Done. It's balanced. Okay? If only they were that easy. And then we'll look at this one that's over here on the left. I have the same number of AS's on either side, but my oxygens are different. So you're going to add 4 waters to balance the oxygen. Then you're going to take a look at the hydrogen. You have 8 plus 3, so you have 11 hydrogen on the right-hand side. I've only got 3 on the left. So you're going to go ahead and add 8 hydrogen ions to the left-hand side. Then you're going to add electrons. The right side is neutral. The left side is a positive 8. So you're going to add 8 electrons to the left side. Okay? Now, you need to make the number of electrons match in each half reaction. If you have 8 here and you have 2 here, you would have to multiply this half reaction by 4. So you're going to distribute the 4. That's the most common mistake I see. Distribute it to each substance. So you have 4 zinc ions, and then you have 8 electrons. Now that the half reaction is balanced in terms of the number of electrons, you can bring both of them together. So when you bring both of these together, the order doesn't matter. Just make sure that you write all the reactants together on the left, all the products together on the right. So here we've got 8 electrons, 8 hydrogens, H3ASO4, and then 4 zinc. And then on your product side, looks like this. Okay. So just to make sure you understand, all of this is here. Okay. And then this I put over here. And then this is here. And this is here. Okay. At this point, we can go ahead and cancel out whatever is the same on the left and the right-hand side. So that means my electrons are now gone. And they didn't tell us that we were in basic solution, so now you are done. Okay. Do you want to try number 2 on your own? Yeah.
If you were in basic solution, would you do the adding OH when you separately balance the redox reaction?
No. You would add hydroxide. You would add hydroxide before I canceled my electrons. I would go and I would add hydroxides. I mean, you could cancel the electrons, but you would add 8 hydroxides to either side.
You wouldn't do it when you're separately balancing.
No. You always do it after you recombine them. Okay, why don't you guys do number 2? Let's see what you come up with. Okay. Did you get something similar to that? Oh, thank you.